Dear students, welcome to our lecture series of Calculus 2. This is our second lecture, and today's topic is integrating trigonometric functions. And since it will be a very large lecture, so I divide this lecture into two parts. In part 1, I will discuss reduction formulas, and in part 2, I will discuss products of sines and cosines and product of sec and tan. Let me start the first part in this video, which will be reduction formulas. Now the first question is why it is called reduction formula. And you see there are four formula I am going to discuss. The first one is for sin x, second one is for cos x, third one sec x, and the fourth one tan x. And reduction formula actually is doing what? It's integrating powers of sines, cosines, sec and tan. So, and all formula here I write holds true for n greater than or equal to, and n should also be a positive integer. So here n need to be a positive integer and it should be greater than 2. Why 2? Because when n equal to 1, you don't need to use this formula. In that case, we already know integration of sin x equal minus cos x. So you don't need to use this formula. But when for n greater than 2 or equal to, you can use this formula. So the first question is, you see why this formula is called reduction formula? Because this formula reduces the power of sine, cosine, sec and tan. Here you see when you will integrate sine to the power nx, then the power will reduces by 2. For example, if you integrate sine to the power 3x, then it will reduces the sine power from 3 to 1. If you integrate sine to the power 7x, then it will reduces the power of sine into 5x. Let us try to prove this formula first, and before that let me show an example how we can use this formula. For example, let us integrate sine to the power 3x. So by using this formula, you see I just need to replace n by 3. So minus 1 by 3 sin n minus 1x cos x plus 3 and n minus 1 equal to integration of sine to the power 3 minus 2x dx, because n equal to 3. So here n minus 2, 3 minus 2, which is equal 1/3 n square x cos x plus 2 by 3 sine to the power 1x means sin x dx, which is equal 1 by 3 sin square x cos x plus 2 by 3 and integration of sin x equal minus cos x plus integrating constant c, which is equal 1 by 3 sin square x cos x minus 2 by 3 cos x plus c. So this is the answer. Sometimes you need to remember this formula. So there is a technique how can you memorize this formula. You see, for sin x you need to start with a negative sign, and which is equal 1 by n, the power will reduces by 1 sin to the power n minus 1x cos x, and in case of cos 1 by n cos to the power n minus 1x sin x, and the second term is same n minus 1 divided by n minus 1, and the power of sine is going to reduces by 2, and here also cos is going to reduces by 2. So let us try to prove the first one. I equal integration of sin n x dx, which we can write sin to the power n minus 1x into sin x dx. How? Because x to the power n, we can write x to the power n minus 1 into x to the power 1. So we can write sin to the power nx is equal sin to the power n minus 1x into sin x. Now we are going to use the formula for integration by parts. So let's say the first one is u and second one is v. So by using this formula we can write sin n minus 1x integration of sin x dx minus derivative of sin n minus 1x integration of sin x whole integration. So which is equal integration of sin x equal minus cos x. So we can write minus sin n minus 1x cos x, and since here again integration of sin x equal minus cos x, so this minus will be plus, and the derivative of sin to the power n minus x will be what? Let's see it here. Derivative of sin n minus 1x equal n minus 1 sin power will be n minus 1 minus 1, so n minus 2x, and derivative of sin x equal cos x. So we can write it here, and actually it's a constant, so we can take it out of integration, n minus 1 into integration of sin n minus 2x dx into cos x into integration of sin x equal minus cos x. So we already make this minus into plus because of this negative sign, which is equal this, and this equal negative sin n minus 1x cos x plus n minus 1 into sin n minus 2x, you don't need to put dx here, into cos square x dx, which is equal minus sin n minus 1x cos x plus n minus 1 sin cos square equal 1 minus sin square sin n minus 2x into 1 minus sin square x dx, which is equal minus n minus 1 into, we need to multiply it, so integration of sin n minus 2x dx, this plus and minus will be minus n minus 1. We can also multiply sin n minus 2 into sin square, and this 2 and this 2 will be cancelled, so integration of sin n x dx. Now you see we consider sin n x equal to I. So here you have another I in the right side, so you can take it to the left side, which implies you have one I already in the right side, and if you take it in the left side, then it will be plus n minus 1 into I, which is equal this. do it by yourself. So in the left side, you see you have only n, because 1 plus n minus 1 is equal in. So finally we can write I equal minus 1 by n sin n minus 1 x cos x plus n minus 1 divided by n sin n minus 2x dx, that is I dot e dot means that is integration of sin n x dx equal minus 1 by n sin n minus 1 x cos x plus n minus 1 by n sin n minus 2x dx. So this is the formula we want to prove. And similarly you can prove the other formula for cos x. And how about the third one? Third one is this one for the sec nx. So let's say sec nx equal sec to the power n minus 2x sec square x dx. In this case you need to expand it like x to the power n minus 2 into x to the power 2, because we know this formula sec square equal 1 plus tan square. So you see sec to the power nx equal sec to the power n minus 2x sec square x, and before we used n minus 1 and 1, but here we are using n minus 2 and 2. Why? Because we know this formula integration of sec square x equal 10x. So now we can again consider this one u and this one v. So sec n minus 2x integration of sec square x minus derivative of sec x n minus 2x integration of sec square x whole integration, which is equal, since sec square x equal 10x, so it will be sec n minus 2x 10x minus derivative of sec to the power n minus 2 equal n minus 2 into sec to the power n minus 3x, and derivative of sec x again sec x 10x sec x 10x. So derivative of sec to the power n minus 2 equal this, and integration of sec square x equal 10x. So this equal n minus 2x 10x minus, you can take it out of integration n minus 2 integration of sec to the power n minus 3 into 1. If you multiply sec to the power n minus 3 into sec x, then you will get n minus 2x, and 10x times 10x, 10 square x equal sec square x minus 1. So this equal sec to the power n minus 2x 10x minus n minus 2. If you multiply this, you will get sec n x dx. This minus and this minus will make plus n minus 2 into integration of sec to the power n minus 2x dx. So you have one I in the left side and another I in the right side with coefficient n minus 2. So you can take it to the left side, which you will get I plus n minus 2 into I. So which is equal I into 1 plus n minus 2, which is equal I into n minus 1. So it means finally in the left side I have I into n minus 1, which is equal sec x minus n minus 2x 10x minus n minus 2 integration of sec n minus 2x dx. This implies I equal sec n minus 2x 10x divided by n minus 1 plus n minus 2 divided by n minus 1 sec n minus 2x dx, that is integration of sec n x dx is equal sec x minus n minus 2x 10x divided by n minus 1 plus n minus 2 n minus 1 sec n minus 2x dx. This is the reduction formula for sec to the power nx. And how about the fourth one? For the 10x, integration of 10 x dx is equal integration of 10n minus 2x 10 square x dx, which is equal, we know 10 square equal sec square x minus 1. So 10n minus 2x into sec square x minus 1 dx, which is equal integration of 10 n minus 2x sec square x minus integration of 10 n minus 2x dx. So in the reduction formula you have this one, but how can we simplify this one or integrate this one? To integrate this one, we can use method of substitution by letting 10x equal z. So if you let 10x equal z for the first integral, then you will get sec square x dx equal dz. So this integral now will be z to the power n minus 2 into dz minus integration of 10n minus 2x dx, which is equal integration of 10 to the power n minus 1. It means 10 to the power n minus 1 divided by n plus 1. So you see z to the power n minus 2, integration of z to the power n minus 2 is equal z to the power n minus 1 divided by n minus 1 minus integration of 10 to the power n minus 2x dx. So now you can put your z, which is 10x. So 10x to the power 10 x to the power n minus 1 divided by n minus 1 minus integration of 10 to the power n minus 2x dx. So that is, in the left side you have 10nx dx. So this is your reduction formula for 10x. 10 to the power nx equal 10 to the power n minus 1x divided by n minus 1 minus integration of 10 to the power n minus 2x dx. So now the next question is, how can we use this formula? So I already show you for the sine case by letting n equal to 2, or now let us say n equal to 4 in example. Now you see we have 4 reduction formula. So let us try to see how can we use this formula. So let us try this one, example 2, sine to the power 4x. When n equal to 4, then by using reduction formula we can write 1 by 4 sine n minus, it should be n minus 1. So n minus 1 means 4 minus 1, therefore sine 3x cos x plus 4 minus 1 will be 3 integration of sine 4 minus 2 means 2x dx, which is equal minus 1 by 4 sine 3x cos x plus 3 by 4. Again you can use reduction formula here. So it will be minus 1 by 2 sine 2 minus 1 sine x cos x plus 2 1 integration of sine to the power 2 minus 2, it will be 0. So it actually 1 dx, which is equal minus 1 by 4 sine to the power 3x cos x minus this plus and this minus will make minus 3 by 8 sin x cos x plus 3 by 8 integration of 1 equal x plus c. So it can be your answer, or you can simplify it by writing 1 by 4 sin 3x cos x minus 3 by 16 to sin x cos x plus 3 by 8x plus c, which is equal minus 1 by 4 sin 3x cos x minus 3 by 16 to sin x cos x equal sin 2x plus 3 by 8x plus c. So it can be your answer. And similarly you can try for cos 4x. So it can be your homework. So please try this one, integration of cos 4x dx. The answer should be 1 by 4 So you can try this one in your apartment as a homework, and the answer should be 1 by 4 cos cube x sin x plus 3 by 8 cos x sin x plus 3 by 8 x plus c. Let's try example, I should put it 3, example 4, integration of sec 3x dx is equal, so this is our formula, sec n minus 2x. So it means sec x 10x divided by 3 minus 1. So it will be 2 plus 3 minus 1, 2, 3 minus 2, 1, integration of sec to the power 3. Instead of 3, it will be 3 minus 2, so sec x dx, which is equal half sec x tan x plus half, and integration of sec x equal what? We know integration of sec x is equal sec x into sec x plus tan x divided by sec x plus tan x, which is equal, you see the derivative of sec x tan x, and derivative of tan x equal sec square x. So we can write ln sec x plus tan x plus c. So I can write here half ln sec x plus tan x plus c. So let me show another example for tan x. Integration of tan 3x dx is equal, by using our formula 4, 10 to the power 3 minus 1 x divided by 3 minus 1 minus integration of tan 3 minus 1 means tan x dx, which is equal 1/2 tan square x minus, and integration of tan x equal integration of tan x equal integration of sin x by cos x dx, and the derivative of cos x equal minus sin x. So we can put a minus sign here, and let me make it plus. So the answer will be half tan square x plus ln cos x plus c, since the derivative of denominator is the numerator, so we can use this formula. And I said in our first lecture that integration of f(x) f prime x dx equal ln f(x) plus c. So by using this formula we can write it. So integration of tan 3x dx is equal to this. So using reduction formula you can calculate any power of sin x, cos x, sec x and tan x. So why not try in your apartment as homework, like number 1 sin 5x and 2 cos 5x integration of sec 5x dx integration of tan 5x dx. So I think if you try to find the answer of these homework, you will understand reduction formula clearly. So that's the end of this lecture, and you will see the second part of this lecture will be in our next video. So please stay connected with us. Thank you very much.